Good afternoon. Yes, I believe I'm for the first time in this process, yeah? So we haven't met already. We haven't. Okay. My name is Alexander Borisov. I am from Russia, from Moscow exactly. And I am the member of the Lebedev Physical Institute of the Russian Academy of Sciences. Here you can see my exact just address. So I would like just to talk with you about the science and innovations in Russia through the support of the Russian Ministry for Education and Sciences. So, but first of all, some few words about my institute. So it's the main building of the Lebedev Physical Institute located in Moscow, practically in the center of Moscow. Yeah. Our institute is maybe the eldest institute of physics in Russia. It dates back to the beginning of the 18th century. At that time, our institute was situated in another big city, Russian city. At that time it was the capital, and the name of this city is St. Petersburg. It's situated on the coast of the Baltic Sea. And as concerns to Moscow, I believe you know the geography well. It's just in the center of the East European plain. In front of our building, you can see the figure of Lebedev, Professor Lebedev, who is considered to be one of the founders of our institution. He was rather famous experimentalist. Once he managed to measure the pressure of light. It was a unique observation, unique measurement. It took place at the beginning of the 20th century. Is my English is okay for you? Could you understand what I'm speaking about? If you have some questions, please, you are welcome at any moment. You can interrupt me freely. I will be glad if you interrupt me. This way, the name of the Lebedev is now the name of our physical institute. And our institute is famous not only just due to Lebedev, but I didn't tell you that maybe the first founder of our institute, at least of the physics or the cabinet of physics, was the Tsar, the emperor. He was already the emperor, the first emperor, Russian emperor, the Peter the Great. Have you heard any time this name, the Peter the Great? Peter the First was one of the Russian Tsars and the first emperor of the Russian Empire. So he was very fond of different sciences and different manufacturing business. And once he traveled across Europe, and collected a very nice collection of physical instruments. And this, after he was returned back to Russia, he decided to organize the cabinet for physics. It was the first, practically the first scientific institution in conventional word, conventional term, in Russia. And so our institution dates back from this occasion. But our institute is not famous only due to Peter the Great or Lebedev, Professor Lebedev, but also due to 6 Nobel winners, Nobel Prize winners, who worked in the Lebedev Physical Institute. Here are photos of Nobel winners, Nobel Prize winners. On the left, you can see the portrait of Professor Cherenkov. Is this name is familiar for you? Cherenkov. Maybe you've heard about the Cherenkov radiation, of the charged particles that move with speed greater than the speed of light in the medium. Have you heard ever? Not heard. It's a pity, but it's rather famous fact, and now he is widely used in various physical detectors. So Cherenkov was the first person who observed this phenomenon, the Cherenkov, the future Cherenkov effect, and as concerns to Professor Frank and Professor Tam, they were the first who explained, who proposed the theoretical explanation of this discovery of the Cherenkov effect. So soon after this discovery and explanation of the of the effect, these 3 physicists gained the Nobel Prize. In the early 90s, in the early 60s, these 2 famous professors invented first done some fundamental works in the quantum electronics and invented first lasers. It was simultaneously done with just one American scientist together. So they are also the Nobel Prize winners. And the last Nobel Prize was awarded as concerns to the Russian, one of the latest Russian winners, Nobel Prize winners, is Professor Ginsburg. Here is the photo of Professor Ginsburg. He died quite recently, maybe 2 years ago only. He was awarded the Nobel Prize for his fundamental works in the theory of superconductivity. By the way, maybe you've heard about the academician Andrei Sakharov. He is considered also the Nobel Prize winners. He is rather outstanding scientist, but he was awarded a Nobel Prize for his activity in the name of peace. Maybe you heard that he was considered to be the father of the atomic, the Russian father, or the father of the not atomic bomb exactly, but the nuclear bomb in Russia. And he worked in our institute for many years. But he got this prize due to his activity in the name of peace, because he understood quite well the tragic possibilities of implementation of atomic bomb. So he struggled for abandonment of atomic weapons. Maybe some questions about my institute. Yeah, welcome.
なんか質問があるかって、レベデフィジカルインスティテュート。
It's maybe the most general physical institution in our country. It has several departments in physics, in semiconductors, in nuclear and physics and astrophysics, in quantum electronics. So practically all branches of physics you can find in our institute. Please, yeah.
I have one question. Please, one more time say the person who give about science from European, the Kaiser's name.
It was Peter. Yeah, Peter. Do you understand Peter?
Yeah.
Peter the Great. Peter the Great is his full name. Yeah.
Japanese say Kyoto, so
Kyoto.
So
Right here.
Yes.
Piotr is much closer to Russian style of pronunciation than Peter. Peter is the English style. Piotr. And Piotr is more correct pronunciation.
Piotr opened the door, Russian door to the Europe. There are many the highest researcher comes from maybe German and French. They prepare some foundation together with the Russian intellectual.
Thank you. Thank you. Professor Misaki-san. He's a good expert in Russian history also. At least
this is the most
history of Russian science.
Of Russia, which the Russian Academy of Science established. And you know, so 6 Nobel laureates produced in this is only in this. Now Saitama University making some agreement with this institute now, especially efforted by the Professor Borisov and Japanese Saitama University, Professor Nakabayashi. Nakabayashi trying to of course as well with Professor Inoue.
So the next part of my talk will be more special, not so interesting for you, but still I have prepared this topic in Moscow and would like to say some words about the science and innovation in Russia through the support of the Russian Ministry for Education and Science. It's Russian Ministry for Education and Science, maybe the chief institution in Russia which has responsibility in financial support and various supports of education in science in Russian Federation. But as concerns, for example, to our Lebedev Institute, we obtain financial support not only from the Ministry for Education and Science of the Russian Federation, but also directly from the Russian Academy of Sciences. But the possibilities of the financial possibilities of Ministry for Education and Science is much greater than the possibilities of the Russian Academy of Sciences. I will explain you, just like you will see later on. So, this slide shows the state measures for the development of science and technology up to 2020. There is a special program of the Ministry for Education and Science for development of the science and technology up to the 2020. What are the main priorities of this program? It's nanosystems, industry, information and telecommunication systems, life sciences, including health, research, and biotechnology. Another item is energy effectiveness, energy saving, and nuclear energy. Rational nature exploitation, transport, and space systems. I don't know whether maybe as concerns to Japan, there are some other priorities in the development of science. Do you know about other important items for development of science and technology in your country? Are there some difference as compared to this list of priorities that are established by the Russian Ministry in Russia for Russia science and technology? Could you tell me something? Misaki-san.
Sorry.
Is it a
such
full-
a 1, 2, 3, 4, 1, 2, 3, 4, 5, 6
Yeah.
items should be promoted by the Russian government.
Yeah.
Big.
They strongly promote just these
But
priorities.
relation with your institute or five technology, five emphasized items. Your institute,
You see,
how to link with
when receiving financial support from the ministry, we usually, for receiving financial support, we usually apply our projects within the rational nature exploitation. Yeah. As concerns to the cosmic rays physics.
cosmic rays.
Yeah. Cosmic rays and cosmic ray physics is considered as one of the important factors that influences the environment.
宇宙船っていう、今この方は宇宙船で呼ばれたわけね。それでは話した。だから宇宙船は環境問題どれで絡まってるのか。
You see, Russian Ministry for Science and Education ordinarily supports the applied researchers, not fundamental researchers. As to fundamental researchers, they are supported mostly by the Russian Academy of Sciences until now.
でもね、話はこの程度、質問した方がいい。
But still, even just if you take the fundamental researchers, it is hard to carry out big projects within the possibilities of Russian Academy of Science only. Big projects on physics demand big funding. So, and it's possible to obtain such big funding only through the possibilities of the Russian Ministry for Education and Science. So, beneath, you can see the main projects that the main instruments maybe that are used by the Ministry, Russian Ministry for Science and for Education and Science. It's the creation of the network of centers of collective usage of scientific equipment. If you have, for example, a big accelerator, it is maintained through the support of the ministry and is considered to be the center of a collective usage which is open for scientists of various Russian institutes or universities. Another instrument, important instrument, is a mega science research infrastructure. I will say about this in detail later on. Mega grant. Do you understand what is mega? It's something huge, yeah? Big, very big, mega. Mega grants are presented according to the state decree number 220 on the measures aimed to attract leading scientists to the Russian establishment of higher professional education, scientific institutions, of the state science academies and state research centers of the Russian Federation. Just a few months ago, we have applied a big project in cosmic rays, which we are going to carry out at the high mountain elevations, mainly at the Pamirs. Just applied such a project to the Russian Ministry for Science, Education and Science within these decree number 220. So another effective instrument of Russian Ministry for Education and Science to promote researchers is the programs for leading universities. It has the name 5 to top 100. So what are the mechanism of state support of science and technology in the Russian carried out by the Russian Ministry of Education and Science. It's the federal targeting program, research and development of the priority areas of the scientific and technological complex in Russia for the years 2014-2020. Another ETP program, development of pharmaceutical and medical industry of the Russian Federation until 2020 and beyond. The government regulation number 218 of 9th April 2012 on the measures of state support of cooperation between the Russian higher education institutions and organizations. Another mechanism is the governmental regulation support of the development of innovative infrastructure in the educational institutions, the government regulation number 220, just I've told you about already about this regulation, which is aimed for the measures aimed for attracting leading scientists to the Russian establishment of higher professional education, scientific institutions of the state, science academy, and state research centers of the Russian Federation.
Sorry? In which items the promotion of fundamental science are included in this?
So, very effective program is the program which is governed by the regulation number 220 on the measures aimed to attract leading scientists. Leading scientists, they can be of the Russian origin or from abroad. We can attract just foreign scientists to the Russian establishments of higher professional education, scientific institutions, of the state science academies. State science academies is exactly the Russian Academy of Science.
2014年から2020年までにロシアがやろうとしている計画です。
Russian Federation. Another important mechanism is the Federal Statute number 291. S means federal statute of the 2nd November 2013 on the Russian Science Fund and amendments to certain legislative acts of the Russian Federation. Thanks to this last federal statute, Russian Science Fund was established. Now it's a very mighty source for financial support of fundamental researchers in our country. Most of our researchers are now governed by this Russian Science Fund. It's quite independent upon the Russian Ministry of Education and Science or the Russian Academy of Sciences. Just starting from this year, we have the possibility to apply for financial support to this fund. So some details about the federal program, research and development of priority areas of the scientific and technological complex in Russia in 2014-2020. The overall objective of this program is to support the development of a competitive and effective sector of applied scientific innovation. Just more specific objectives are the following: to support the development of advanced scientific and technological innovations of an interdisciplinary character in the priority areas, to support the planning and coordination of research and product development, to ensure the integration of the Russian sector of applied scientific innovation into the global environment, including great cooperation, to ensure higher productivity of the Russian sector of applied scientific innovation. By the way, are you familiar with these abbreviation, BRICS? Don't know what does it mean. Have you ever heard about, yeah? Is the abbreviation of the group of states: Brazil, Russia, India, China, and this South Africa. These countries are considered to be rapidly developing countries. Yes. So, and they obtain a rather big economy. Together, I believe they represent about 25% of the whole global economy of the world. Or no, including China, maybe even more, about 40. So, what are the main mechanism of this program? Is the conduction of applied scientific researches. Within this mechanism, about 400 projects could be supported up to 0.6 million a year. This support is provided for 3 years. Another mechanism is the conduction of the applied scientific researches for certain economy sectors. Within this mechanism, about 500 projects up to 0.9 million a year are supported for 3-year period. Another mechanism is the conduction of the complex scientific researches. About 30 projects could be supported within this mechanism, just with 3 million funding a year. Another is conduction of the researches with the international scientific and technological cooperation. It's
and then the projects which initiated by you is included as a candidate in the 1, 2, 3, 4th column. Yeah, your projects.
Yeah. It's the fifth tested
130 projects, up to 1.5 million a year to 3 years. この方が今提案しているのは日本人。
Yeah. So we heard that after the signing an agreement between the Lebedev Institute and Saitama University, we can apply a joint project to the Russian Ministry and maybe to the Japanese Society for Promotion of Science. Also.
Such an agreement surely is available for promotion of your project.
Yeah.
Saitama agreement between Saitama University and the Lebedev Physical Research.
So I hope that maybe in the end of this year or at the beginning of the next year, we'll apply such a joint project to our ministers. So another mechanism is support and development of unique scientific installation. For example, our big emulsion chamber at the Bermudas, which contains about 1,300 tons of lead plates, is considered to be a unique setup. And for its operation, we obtained just annual support within this mechanism, support and development of unique scientific installations. Unique scientific installations, besides astrophysics, like Baksan installation or our installation of the Bermudas, another just big unique scientific installations are various accelerators. We have accelerator in the scientific center, which is situated in Dubna. To the north of Moscow, to the south of Moscow, we have another big accelerator, Protvinov, maybe you've heard.
Now, Professor Borisov trying to expose the very big experimental apparatus that the name and the immersion chamber constructed and the PAMIs in the Tajikistan, together with cooperation with the Soviet Russian Academy of Sciences. This such a similar type of the experiment had been carried out by Japanese side in Saitama University, initiated by Professor Matano, who was a teacher of Professor Inoue. There are two some similar experiments under development. But now, new one. One side is Saitama, one side is the Level Physical Institute, initiated by his professor, Sabachinsky. Now, Professor Borisov are trying to establish a big experimental apparatus in the PAMI. This is our history, Saitama University history.
So, a specific mechanism is supported development of centers of collective use of scientific equipment. Within these mechanisms, researchers at various big setups and installations are supported. They may be accelerators, big astrophysical setups, etc. So, maybe some words about another federal program, development of pharmaceutical and medical industry of Russia until 2020. I wonder, are there some biologists or from among you who are just specialized in biology or medicine? Of you? Okay. Then maybe it will be interesting for you that we have a special federal program for support of development of pharmaceutical and medical industry in Russia until 2020. And the overall objective of this program is advanced innovation in the Russian pharmaceutical and medical industry, and the specific objectives are introduce modern technologies into the production process, ensure that the most important medications, medical treatment and devices used to treat most common serious life-threatening diseases are produced domestically, overcome dependence on imports, support the marketing of innovative products, increase the export potential of domestic medical and pharmaceutical industry. Okay. So now I will speak about the implementation of international coordinate calls in their priority areas by the Ministry of Education and Science of the Russian Federation in 2007-2013. This graph presents distribution of science and technological projects, scientific and technological projects by international partners within the FFP research and development. You see that the 47% of funding comes from European Union. Just as concerns to USA and Canada, only 9%. These countries funding is 14%. Latin America is about 10%, and Southern Eastern Asia is 8%. While the contribution of other countries is about 12%.
Sorry, I have a problem. What country included in CIS?
CIS, right here. Right here. Europe, maybe because you are too young, but in 1991, disintegration of the Soviet Union occurred. And after the disintegration of the Soviet Union, there appeared 15 independent states, and most of them decided to establish a commonwealth of independent states at some union. Named Commonwealth of Independent States. So this is CIS is the abbreviation, Commonwealth of Independent States. Of course, among these CIS republics, the main contribution belongs to Russia. Main contribution belongs to Russia. So, this figure, this graph, presents the distribution of scientific and technological projects by allocated funding within the FTP on the R&D. So, about 64% of the total sum goes to the support of international projects with countries from European Union. Just 6% goes to the international cooperation with USA and Canada. Just about 8% goes to the cooperation among the CIS states, Commonwealth Independent States. Just only 7% go to promotion of scientific researchers together with Latin America states, and so on. So, as concerns to the distribution of scientific and technological projects by the targeted priority areas within the federal program on research and development, the situation is the following. 28% of funding goes to support of the projects that deals with nanosystems and industry of nanosystems. About 12% for information and telecommunication systems. You see the huge amount of this funding, 21%, goes to the life science. It's a very big project for life sciences. As concerns to the energy effectiveness, energy saving, nuclear energy, only 12%, practically twice less. And rational nature exploitation is also a very huge amount. It's about 27%. So we are lucky that the cosmic ray researchers are within these huge amounts, the huge portion of funding. not interesting for you. So now about some words about Russia's involvement in the development of mega-science research infrastructure. I've told you already that mega-science means that you use a mega science infrastructure for your researchers. So, and you need a big amount of money for carrying out such type of researches. So, what are the main projects that are which are supported by the Russian Ministry for Education and Science to promote the mega science projects, mega science researches? They are the following. First of all is the European X-ray pre-electron laser, XFEL. Russia is the member of these projects. There are two main countries responsible for this project. It's Russia and Germany and some other countries of European Union. Another big mega science project is the European Organization for Nuclear Research, CERN. Have you heard about CERN? Yeah? The biggest accelerator, the biggest collider is situated in this European Organization for Nuclear Research. It is located at the territory of two countries, Switzerland and France. When it appeared, it was located at Switzerland, but after the extension of the dimensions of accelerator, the most part of this organization is now is situated on the territory of France. Another important mega science project is the facility for antiproton and ion research, as the name fair, and International Thermonuclear Experimental Reactor, ITER. I believe you also knew about this project because Japan is plays an active part in this very big and ambitious project. Do you know about the ITER project? It's the International Thermonuclear Experimental Reactor. The scientists believe that after creation of this International Thermonuclear Experimental Reactor, the problem of lack of energy will be solved. It will be pure energy without any environmental pollution. So, as concerned to the development of advanced research infrastructure in the Russian Federation, then we have just the big mega science research infrastructure are the following. It's the tokamak emitter. Do you know what is tokamak?
It's most famous.
Yeah.
It's very,
By the way, the idea of tokamak was proposed by Andrei Sakharov. Do you remember? Yeah, his name mentioned at the beginning of my lecture. He is considered to be the author of tokamak. So it's some special device, yeah, of very familiar shape for you. Just this. In Russian, we have the name maybe you have only some such type of piece of bread. So if you use the magnetic fields, strong magnetic fields, it's possible for you to capture plasma, and it's considered to be a very effective tool for thermonuclear experimental synthesis, thermonuclear synthesis. Okay. Next huge just infrastructure located in Russia is the high flux research reactor. It has the name, Russian name is PIC complex. Another big setup is the special synchrotron radiation source for the fourth generation. That is very useful for biological researchers, I believe. Complex of semiconductor rings for heavy ion collider beams. The abbreviation is NICA, NICA complex. It was located in the Dubna Joint Institute for Nuclear Research. Also mentioned already about this International Research Center located at the bank of the Volga River to the north of Moscow. So their most ambitious project is the Nika complex. Another big infrastructure project is the Exaward Center for Extreme Allied Studies. Excels. And electron-positron collider, super tower and shell factory for production of tau neutrino and charm particles. It is under construction in Novosibirsk city. Novosibirsk is considered to be the capital of Siberia, just much closer to Japan than Moscow.
ノボシビリスクは筑波の学園都市のモデルになる。シベリアの真ん中にある。それをモデルにして筑波の学園都市が作られた。
So, if you want to know more details, please ask me. So, I would like, of course, maybe it's necessary for me to wait until Professor Inouye-san will return back to our class, because I would like to express my great gratitude to him and to other Japanese colleagues, to Professor Misaki-san, to give me an opportunity to visit Saitama University and to discuss in details possibilities to extend our long-term and time-proof collaboration in high-energy cosmic rays researchers, and particularly researchers within a new Pamir 21 project. The sympathy I have experienced while communicating, as well as the concerned discussions. Oh, you are just in time. Just in time. It's the most important slide of my presentation lecture. Yeah. So I would like to express my sincere gratitude to you, in particular, for warm reception, for nice discussions, And so I hope for establishment of just good collaboration between the Lebedev Institute and the Saitama universities, and all young students are welcome to participate in this big project, because this project is in for many years. Just the minimum duration is 7 years. So we need young people who like to go to the mountain altitudes. So you are welcome. Maybe I can show you some slides of Pamirs or Mountain Chikaltai. I don't know whether they have some idea how these mountains look like. So, thank you for attention. Please.
質問はまだ Okay, thank you very much for your presentation, seminar. Maybe question time with
Yeah,
the student?
with great pleasure.
さあ、考えてみたら先週も来たんですよね。でそれでゴニゴニやっとったんだよね。さて今日はリベルで明日帰るんですけど、あんまり関係ないか。じゃあ質問を何か受けましょうかね。何の質問でも構わないと思うし、写真もあるとか今言ってましたけれど、それを見てからでも構わないですけど、とにかくちょっと皆さんの様子を聞きますかね。はい、じゃあ何か質問ある人。
他の質問した方がいいですよ。いろんな質問をロシアについて。
大抵質問あるはずだから、間違いないだけだと私、バイク持ってるからはしますかね。はい。あれ。はい。
普通の質問したらいいんだよ、ロシアについて。
Please, any questions about Russia, Moscow, Russians, Russian science, my Lebedev Institute, you are welcome.
I have one question. I think Russia's winter vacations are so longer than Japan.
Winter vacation.
Winter vacation. Because Russia is very cold. So how long the winter vacations?
As concerns to the secondary school, the vacations ordinarily started maybe 2 days before the New Year, and lasted until 10th of January. Nowadays maybe 2 weeks in total, not more. Yeah, and as concerns to the high school, it's even less, about 10 days only. Yeah. Because winter is rather ordinary for us. We're quite accustomed to winters, snow, ice. It's not a problem for us. It's not a problem for the traffic. We're quite accustomed to such problems.
予想外ですね。
Yeah. So these are some pictures of the just future experimental site we chose 2 years ago at the Pamirs. So this vast valley is within the Pamirs, within the so-called eastern part of the Pamirs, and this valley is located at the height of 4,260 meters above the sea level. So the height of this. Do you know what's the height of the highest mountain in Japan? And what is the highest mountain?
Mount Fuji.
Fuji. What's the height?
3,700.
So here you see the high altitude plateau. The height of this plateau is more than 1,000 meters above the sea level. You see, it's the plateau. It's occurred due to moving of geo platforms due to the colliding of those geo platforms which rise the mountains at the heights of more than 4,000 meters above sea level. So we choose this nice valley for deployment of new experimental site. Maybe you see this is the beginning of construction of some shed which we need for displacement of the central part of our future installation, of our future experimental setup. So this distance from these buildings to this is about 1 kilometer. So the initial area, the initial dimensions of our experimental site setup is as big as 1 kilometer, square kilometer. So to get to this valley, we need this road, and so 2 years ago this road was done to ease the transportation of heavy loads. So this is the same valley, but from the neighboring hills, the view of the same valley. So you see, the dimension of this is like a crater, yeah, maybe. So the dimensions of this valley is about 5 kilometers in length and 2 kilometers width. Here you see these housing buildings, and this is the construction of the concrete base for future setup. You can see. So this direction is directly to the east. Just maybe in the direction of Japan. Yeah. But just geographically, this place is close to the western boundaries of China. It is close to China territory. Afghanistan is to the south west of these trees, and India is not so far also. Just there is a narrow piece of land which belongs to Afghanistan, which separates Pamir and India, for example, Himalaya. So it's the construction of the concrete base for the future setup, And nearby we have a nice lake, and this lake has such wonderful fish, full of fish. It's very strange how it survived in these conditions, because during the winter the temperature can be very, very low, up to minus 40 degrees. So I believe all the lake should be completely frozen, but still it survived. Maybe there are some thermal springs, thermal sources. This is the lake. So the height of this lake is about 4,100 meters above sea level. Wonderful. Very picturesque. This is the lake. Here. So, if you go across, sorry. If you go across this mountain range, you will get to the Afghanistan territory. But fortunately, there are only mountains, and mountains, because it's impossible to cross these mountains from just the direction of Afghanistan. Of course, there are some boundary forces guarding the boundary. So, just a few photos.
Just
if you have some questions, please.
One question, Borisov-san. One question is coming.
Here it is. Ah, okay. Wonderful. I have found the map of the Pamirs. Do you want to understand where it's the location? Maybe it's so maybe this is rather old map, and it's for alpinists, mountain climbers, but it's better. So you can see this is the boundary with the China. This is. Here you have Afghanistan already. Yeah. Unfortunately, there are few. So, as concerns to our place, it's somewhere here. Or even here. Yeah. So if you cross this mountain range named Bahan mountain range, you will be not exactly at the Afghanistan, but in China. Afghanistan just from this place.
How many kilometers from the campus of the experiment to the borderline of China? How many kilometers?
About 100.
Only 100? Only 100?
Yeah. The nearest, yes. Well, it's better. Yeah. So you can see the city Osh. In this city, we have our Pamir expedition base, and we use it just to go to the Pamirs. It is possible to get to the city Osh from Moscow by airplane. So, and in this city, we take the vehicle and goes along the Pamir highway that crosses the Pamirs. First it goes to the south, just passes nearby this big lake, Karakul, the name of this lake, and soon you appear in Murgab. And this village is Chichiti, the location of the first high altitude mountain station that was built by Lebedev Institute in the 40s. So after these several points, just to the right here, you have our next experimental site, Akarhar, with the mountain chambers. And opposite this point, if you go this in this direction, you just arrived at the new experimental site, Kolochkul experimental site. Yeah. So, as concerns to the Pamir highway, it goes just after the Murgab, it goes practically to the west and arrived at Kharok city. Kharok city is the capital of the Pamir Autonomic Republic. And from Kharok, just to the north, west, and you appeared in Dushanbe, the capital of Tajikistan. So from Kharok to Dushanbe is about 700 kilometers. So in total, from our place here through Kharok to Dushanbe, it's more than 1,000 kilometers by highway. So to get to our experimental site, the way through Osh city is more convenient.
How long times Pamir from Osh by?
It takes about 10 hours for us, ordinarily, yeah, to get there by vehicle. Maybe now it's even less because this part of the track, Osh, and just until this saddle point, is absolutely renewed recently. It's a very, very nice road. It's possible to move with velocities greater than 100 kilometers.
時間も限られてきてるんで、一問一答でも簡単な質問でもいいですね。わかります。
One question. Where last week we took Tokyo?
Yeah, last week I visited Tokyo.
Where?
Exactly. Just climbed the sky, Tokyo sky tree. Yeah. I enjoyed very much. We have also a very tall tower in Moscow. It was erected in the middle of 60s, and at that time it was the tallest tower in the world. The height is more than 500 meters, 540, I don't know exactly. Yeah, but now it's not so high like as just Tokyo Skytree.
I have two questions. One, firstly, what is the most what is mainly research at the LPI
Institute, Physical Institute. It's hard to say about just the main research trend in our institute, because we have, I've told you already, that we have several big departments. Each of these departments is considered to be some kind of independent institute within the joint institute, Lebedev Physical Institute. And just each of the departments is dedicated, for example, to quantum electronics, optics, nuclear physics and astrophysics. It's different departments. And it's possible to see what are the main researchers' main experiments, for example, in a specific department. For example, in our department, as concerns to the nuclear physics and astrophysical department, where I work, main direction of the researchers is cosmic wave physics, various experiments, and Pamir experiment, just easily, and priority experiment in our department, and so on.
Thank you. Second, do you feel the difficulties of students of Japanese university and the Russian students of Russian university?
I'll try to guess your question. Yeah, I believe no difficulties for communication. Yeah, of course, it's necessary to speak one of the common languages, at least. If it's not Russian or Japanese, then maybe one of the favorable languages is English. So at any rate, it's possible to communicate using English. I believe no problems in that case.
And now, the Russian university have some programs where students from all countries lectures given in English. Some programs they
in Russian, of course. There are a lot of foreign students in Moscow State University, for example. But you see, when a foreign student come to Moscow State University, ordinarily it is necessary to first to study Russian.
yes.
It demands about 1 year to learn Russian, and after that you have the possibility to attend lectures, seminars, and etc.
It is quite natural for foreign people who study to the Russian university are requested to master Russian language.
Yeah.
Of course, it is very natural.
Russian language is not so complicated as compared to the Japanese language. So,
No, Russian language is not so complicated
Yeah.
compared with other European languages. Our language is quite isolated language, Mongolian oriented. So grammar is quite different from European ones. But Chinese, for example, Chinese construction of the Chinese sentence are similar to European language. But Japanese is different. So for Japanese, it is somewhat difficult to understand the European language. If they can speak, understand the European language, it is not so difficult to understand Russian, but only alphabet is quite different from Russian alphabet is quite different from, but this is only symbol problem. Oh, you are requested to learn Russian. It is not so difficult. We can do
already
read Russian papers.
To learn Russian is much easier if you have some notion about the English language, so it's quite easier in that case to learn Russian. Because the Russian alphabet or Cyrillic alphabet is quite similar to the Latin alphabet. So there are many words in common in Russia with European languages, the Latin origin, for example, or English origin. So it's not difficult. It will be not difficult for you to learn Russian.
じゃあこの辺で一度締めますということで、ちょっと私また会議が始まるんで行きますが、写真まだ撮ってないんだよね。ごめん、君今度撮って写真撮ってもらって、それでこの場所を締めていただければなと思います。はい。
Okay, take picture. We'll go and advise of Professor Inoue-san. He's hurry for his other classes here. So let's take a picture of us. Please. Next. Maybe we'll stay together with Professor Misaki-san, just in the center.
I am the host. You are guest.